So today's lecture is on data storage, which is mostly databases and a few other data exchange formats. And I just want to highlight once again, this is another semester-long course that's really just packed into a single lecture. It's intended to be an introduction, not the end of the story, and all we're really going to talk about are high-level questions like what is a database, what are the various types of databases, and how do you optimize databases. I would even add to this maybe one more point: the data exchange formats that we're going to be talking about at the last section of the lecture. So, what is a database? A database is any coherent collection of data organized around its inherent meaning. So, essentially, a set of random data is not a database, even if it's organized in a highly structured file. If it's randomized, it's really not. Like, it has to be structured around the meaning of the data. So, for example, a random collection of files from my computer could include things like books, movies, articles, totally unrelated data formats for various applications that I have running on my system. That is not a database. It's a file system and it includes a whole bunch of stuff, but it's not a database in and of itself. We really have to have it optimized and structured for a particular purpose. Usually these are going to be updated on a regular basis, usually in response to real-world events. Sometimes those events happen very rapidly, so collection of sales for a credit card company would be a good example of that. And sometimes they take a very long time. Census data is a good example. We have lots of census data that is not collected any more than once every 10 years or so. So very important to look at the update profile. Databases can be large, small, everything in between. You've got databases on mobile phones. You've got databases that could only ever exist in the cloud because they're so massive you couldn't put them all in a single system. And the main reason why databases are useful isn't so much all of this optimization or the regular updates or the software that manages the system itself or all of the size potentials. It's the efficiency and convenient access for multiple people to massive amounts of persistent data. And that's the thing that makes a database very different from pretty much any other kind of storage. Efficient access from multiple people at the same time of a large collection of data. Now, in class, I would normally have you go through this exercise where you're writing down as many examples of databases as you can, noting that the database that I'm interested in is the actual collection of data and not the software that runs the database. So most people, when you ask them what's a database, they'll say something like, oh, it's Oracle, or it's MySQL or Postgres or something like that. Those are not databases. Those are database management software packages, DBMSs. And if you come from a STEM background, it's easy to refer to them as databases when in fact they're not. A database would be something like the UMBC library database. Right, specific, organized around an inherent meaning, updated regularly, maybe somewhere in between small and large, a medium-sized database, if you will. Other databases could include things like the set of friends that you have on Facebook, the number of people who are enrolled in your classes. All of this could count as a database. So let's look at one very quick example of what a database is and give you one of the key concepts in a relational database. So in this particular case, we have a database with two tables, a student table and a grade table, and they are related, and I'll show you how they're related in just one moment. First, I want to show you that the students are organized around their inherent meaning, right? We've got a structure to a student. The student has an ID, they have a name, a class, and a major. And we're organizing it such that the ID is a unique identifier for each of these students, right? Everyone at UMBC has a student ID, and that uniquely identifies you amongst all of the other students here at UMBC. The name, the class, the major, all of this is stuff that can be updated or changed, but the ID really should stay consistent and unique. When you want to relate a student from the student table to a grade in the grade table, you have to have some mechanism for doing that. And in this case, we take the ID from the student column and import it into the grade table, and that allows us to look up grades for a particular student, right? So if we're interested in knowing what grade Smith got in various courses, we would take student ID 17, look it up in the grade table, and then we could see, oh, for course number 310, they got an A. For course 317, they got a B, right? This saves a ton of space because if you imagine taking the course and the grade information from the grade table and importing it into the student table, then we would have a lot of repeated information. You'd have to repeat the ID, you'd have to repeat the name, you'd have to repeat the class, you'd have to repeat the major, all the way through in order to just have small changes here and here for those courses and grades. So that's massively inefficient, and by relating one row from one table to another row in another table, or possibly many rows in another table, we can be much more efficient in terms of storage and access. All right. So another activity that I would typically do here is to create an additional table, a courses table, and then relate that using the course number as the ID from this previous table. So this course number here, right? And then you could add in things like the name of the course and who's teaching the course and possibly a syllabus and all that sort of stuff. I think these are good activities, things that I would encourage you to do on your own. They're not particularly helpful in terms of studying for the final exam, in part because we're not going to have questions like this on the final exam, but they are things that will help you get a better intuitive understanding of what a database is and how they work, especially if you do not come from a STEM background and this is the first course that you've had introducing you to databases.